In this video, we're going to look at some approaches to authentication that we can use in our Spring Boot applications. When we're writing a RESTful API, the overarching constraint is that that API should be stateless. And that means that we don't store data about users within the API between requests. And so that would rule out using session data in the API itself. A common approach, if we just focus on the web side of things, is to have a view where we present a login form. The credentials will then be sent to a controller, which will contact a database if we're not using an API, use the database information to validate and authenticate the credentials that have been provided, and if the credentials are correct, to store the user information in a session attribute, so that when a subsequent request is provided by the user, the controller can check to see if that user is still logged in by looking in the session information. And if the user is logged in, do some authorization, and if it's authorized, go ahead and process the request. Eventually, the user will log out, in which case the controller will remove from the session data the user information. And that signals that the user is now logged out, so that if any other requests come in, the user is logged out and therefore the request cannot be processed, unless of course it's a login request. Now, if we take that concept a little bit further using an API, then the login information that is sent to the web controller will then be sent to the REST controller, which contacts a service that uses a repository to get the user that matches the credentials. The verification of the passwords can take place within the service, and if the credentials are correct, then the controller can send a data transfer object back to the web application, and that web application will then store the user information in its session. And in this way, we've avoided any session information being stored in the API. It's being stored by the client instead. But there's a couple of problems associated with this approach. The authorization is being done in the client. And therefore, if we have multiple clients, that authentication and authorization is being repeated in each of these clients. So we're going to have to write the same code multiple times in different types of client. Therefore, it would be much better to write the authentication and authorization code in the REST API so that it's written once and then it can be used from any type of client. And the approach that we can take, one of many kinds of approaches, would be to have the client, in this case a web application, send in a request for credentials to be checked. The REST API would use the information stored in a database to validate those credentials, and if the credentials are correct, the API would then create a token which it stores in that user's record in the database, and returns the user information, including that token, to the client. Then, on subsequent requests, the client can send that token along with the request so that the REST API can use the token to find that user's record. If there is a matching user, then that user must be logged in, and then the authorization can take place. Later, when the user logs out, the client will send a logout request to the API, which will delete the token from the user's record, and that's a signal that the user is logged out. Now, this is a bit of a simplistic approach to authentication and authorization, but it will work, as I will show you when we examine the code that I've written for this example. But there are better ways, more sophisticated ways of doing it, and you can look those up when you do some background reading. Now, the approach that I'm going to show you is using a web filter for the authorization. Now, a web filter essentially intercepts the request that the client sends to the API. When it intercepts the request, it will check that request for the token that is entered in the authorization request header. It will then use that token to extract from the database the relevant user information, thereby obtaining the role that this user has. And if the roles grant permission for the requested resource, the request will then be forwarded to the API for processing. If the authorization is declined, then the filter will send back to the web application a response that says the request is not authorized. Now, writing a web filter is actually very straightforward. We have a standard class that will implement the filter class and therefore needs to override a DoFilter method. We've annotated the class to be a web filter, and we provide a list of URL patterns for which this filter will be used. And so whenever a request is submitted that matches one of the potentially many patterns listed in here, this filter will intercept that request and will execute the DoFilter method to determine whether the request can be processed or not. Let's take a little look at some of the approaches that we could take in DoFilter. The DoFilter method receives request and response information as a parameter of type servlet request and servlet response. And so what I'm doing here is typecasting the servlet request and servlet response into the HTTP version. And that will then allow me to get from the request the request URI, convert it to lowercase and store it here so that I can then examine what resource is being requested. If the request is to check credentials or to create a new user record, then I don't need to do any authorization for that. And therefore, I'm immediately calling filterchain.DoFilter. Now, filter chain is the third parameter here. This is given to us because our filter might be one of many that have been formed into a chain. And so when a request is received, the web server is going to build a chain of filters that are registered to process that request. When our filter has finished doing its work, it will pass the request on to the next filter in the chain. And it's possible that there were other filters earlier in the chain that have done their processing before sending the request to our filter. So if we want to send the request on, we just call filterchain.DoFilter. Eventually, when the last filter in the chain has processed and accepted the request, calling filterchain.DoFilter in that last one in the chain will effectively just forward the request and response on to the API. Now, we can do other processing in here to perform authorization, but eventually we might determine that the request is not authorized, in which case we will use the response object to send an error back to the client, and in this case we're going to send a status code unauthorized, which is the 401 response. So let's see how this can be done. I'm using the PETS case study for this, and I've added to it some authentication and authorization code. Before we look at the code itself, let's examine some of the diagrams that tell us a bit more about the application. One of the amendments that I've made is to make some of these use cases available for use by both actors. Others remain available only to one actor or the other. In this diagram, I'm showing the situation where both types of actor are able to perform a use case, in this case, check credentials, and I'm showing that it can come from one type or another type of client. And I'm showing the requests that will be made. I've also reordered some of the elements within the requests so that there is a more consistent approach to this, and that makes the authorization a little bit easier, as we'll see in a few moments. And so all of these diagrams now are indicating whether one or the other or both types of actor are able to use these resources. The other thing that I've added in here is an indication of the authorization requirements. So for creating a new owner or for checking credentials, there is no authorization to be done. But if we are trying to update the address of a specific owner, then only the owner can do that. And the authorization is that the owner must be logged in and the ID here matches the ID of the logged in owner. And so there's a whole load of other requirements listed for each of those types of request. Now, for me to be able to do this authentication and authorization, I need to add to the database some information. So for the owners, as well as all of the other information that was there before, I've added in a token column. And this is going to store the token when it is generated upon successful authentication. And I've also put in another table, this time for staff, that will have the basic information, including a token column. So that's what I've added into the database. And therefore in the classes, I need in the owner entity to add a field for the token that has now been added into the database. And also in the service to be able to check credentials based on token and to log out. Similarly, for the staff, which is a new table in the database, I've got a new entity for staff, a new repository for staff, a new service for staff, and a new controller for staff. So those are the additions that I have made to the code. There's also the filter that I've added in for the authorization. So let's take a look at how the authentication is done in the code. In the owner controller, when we are asked to create an owner, we call the create owner method in the owner service. This is going to create the owner by calling the create owner command. So if I come now into the command package and look at the create owner command, you'll see that I'm checking to make sure that the email is not already in use. And then if it isn't, I will go on and save this new owner in the repository in the database. Having created that owner, we're then able to check credentials. And when the owner has been found in the repository, in the database, if that owner is not null, in other words, we have found it, and if the password that has been provided matches the credentials that we've been given, then we are going to authenticate the user. And as part of that approval, we're going to use this hash string method from the string hasher class, which is down here in the util package. And you can see from the highlighted code here, this is what I was showing you in the previous video about hashing passwords. And I've just copied and pasted the code to perform the hashing. And so I'm generating a hash, which in this example is to get the owner's email, which is going to be unique to that user. Follow that with a colon and then the date just now. Put that all as a string and then hash that string, which will give me a token, which I then store in the owner object, save it back into the database, and then return that owner, which includes this token, back to the owner service, which then returns it back to the owner controller, which returns it as a DTO back to the client, and then the client can store it in its session information. Then that token can be used on subsequent requests. And as an example of how that would be done, let's take a look in the generated requests. I already indicated that check credentials does not need authorization, so we don't need to provide it. But when we want to perform some other kind of request, we must provide some authorization. So we use the header called authorization and provide the value of the token. Now in the database, if I'm doing this from the owner, I can go to an owner and I can get the token from here, copy it, come back into there and paste it in here. And then I know that I'm using a valid authorization token. And I can do that for any of the owners that are logged in. So I can work my way through here. There's a put request to put an address. I would need, if it's from the wrong owner, then I expect it to be rejected. If it's from the right owner, I would need to put in the correct token and then put this information and expect it to be updated because the authorization should permit that operation to be performed. When I want to make use of the authorization in unit tests, in this case integration tests, I will need to provide a header called authorization with a value for the token. Now, in some ways, this is a bit easier because when I'm doing my integration tests, I'm clearing out everything in the database. I'm creating a new owner and I'm just inventing a token. It doesn't really need to be hashed at this point. It's just for the test. So I'm using a bit of plain text there. I then save that owner with that token in here, and then I'm sure that my token that I'm providing for the authorization header is going to be matched. And then I can perform my test. It might be that I expect the test to be rejected because it's not authorized. And if I want to do that, then I can test the status and expect it to be unauthorized. So we're able to make good use of this authorization and verify that that is working correctly. Let's take a look now at the way the authorization is done. So I've got another package here called filter, in which I have the authorization filter, which is my class. Just as I was showing you a few minutes ago, we're implementing the filter. It uses the web filter annotation, and I'm using this filter to intercept every single request to the application. Now in the DoFilter method, as well as typecasting request and response to be the HTTP version so that I can get the request and check it, as I mentioned earlier, these two types of request need no authorization, so I'm just passing the request and response on to the next filter in the chain. But if that is not the case, then I need to do some authorization. So the first thing I'm going to do is to see if this is a member of staff that is authorized to perform that request. And so we come down to this method, which is the staff is authorized method. I'm getting the header information for the authorization, which is my token. So I'm storing that in here. And then I can use the staff service to check the credentials based on that token. That's going to return either null or a staff entity that matches that token. And so if the staff is not null, it means I've found a member of staff that holds that token, and then I can test to see if the request I've received is one of the permitted requests for a member of staff. If that is the case, I'll return true. And I've done something similar here for the logout, but in this case I need to make sure that the logout is requesting logout for a staff ID, which is the same as the staff that holds this token, because I don't want staff number 1 trying to log out staff number 7. That wouldn't be appropriate. So if it's staff number 1 that's making the request, and it's a request to log out staff number 1, then I can return true, otherwise it'll return false. If the staff is authorized, then just forward the request on as we did up here. And so the request is now authorized. Similarly for the owner. If the owner exists with the token that has been provided, and the request is for something permitted for an owner, then return true, otherwise return false. And that means that either I have an authorized member of staff, or I have an authorized owner, or if none of those matches, it means that the request cannot be authorized. And so we send back to the client via the response object an error that is unauthorized. And that's it. That's the authorization filter. It's very straightforward to do. We write this class, we give it the web filter annotation so that it will intercept the requests. And if everything is authorized, the request is then forwarded on to the appropriate controller, as we have seen in previous videos. Now, this approach is just one of many ways to perform authentication, and so I do recommend that you undertake some background reading about these other approaches. For example, learn more about web filters, which is what I've just shown you. Also, Spring Boot filters, how to do stateless authentication with JSON web tokens, or how to use session management.